This is the setup for the predicting distance from momentum lab. Since this is a capstone lab, I'm not going to give you as much detail as to what formulas to use. If you really get stuck, I can help you, but at this stage, we're getting ready to take a test. We should be able to use the formulas and use what we've learned to actually make predictions and see how accurate you are. So the purpose of this is to tie together the kinetics information, formulas, and we learned from Unit 1 and Unit 2, and tie that together with some of the momentum equations and concepts we've learned, and see if we can't do a multi-step problem. In your lab notebook, I refer to everything down here as 2. So the distance this cart goes will be x2. The mass of that, now in this picture I used a 1K, I used 1,000 grams. It turns out that's a little bit heavy. So in your lab you're going to use a 500 gram weight. And we'll have some clay, molding clay here to catch the ball. And all that together would be m2. The distance the cart goes is x2. The time it takes the cart to go that far would be t2. The distance, not the height, the distance up the ramp will be x1. Now, you're going to need to remember the ramp, the numbers on the side of the ramp, which is the ones were used. The ball bearing doesn't go to the end of the ramp. So what you'll need to do is just go straight across from the cart to the ramp and read your data that way. In the instructions, you will place the ball at 50, but the distance up the ramp is not going to be 50, because ignore the curve part, just assume the ball is going straight down and over. It averages out because my curve is less steep here, so even though the distance is a little longer, you'll get basically the same result like we did in the lab in the Unit 2. If you just count the distance from where you release the ball to where the ramp ends right here, which is not the end of the entire metal ramp, but where it comes off the Hot Wheels track. A couple of close-up pictures to keep in mind. I have found, and you can adjust this, you're not going to take very much data, so you may play around with it a little bit. This is the setup, the part 2 setup when I've added the 200 grams. You notice I taped it together so this part wouldn't go flying off. You're not going to take a lot of data, so if you need to make some adjustments and try 2 or 3 trials to get it to work, that is fine. I found if I have a little gap here, the ball bearing is less likely to bounce off because I need the ball bearing to stay inside this shape. If you mold the shape just right, the ball bearing will stick, but most of the time my ball bearing will hit and bounce around, but it has to stay on inside the yellow clay. I molded the clay here. You may come up with different ideas, and I've got the weight of the clay leaning forward to help absorb to keep it from flying off the ramp. So if you want to play with that some, I think you'll have time to do that. There's another picture of how I had it designed, so when I'm done, that ball bearing needs to stay in there when it hits, and then the cart's going to slide down the ramp. This has to be level. This should be set up, but just keep an eye on that. I think earlier I had actually to where it was tilted up, and that really messes with your with the ball bearing, bounces all over the place when you do that. The first thing I'm going to do is I'm going to release the ball 3 times because I want to make sure my setup is consistent, because it doesn't do us any good if I release once. If I'm getting different values, if this slides 5-6 centimeters different every time, then the lab's not going to work. The whole range should say be from a couple of centimeters difference. From the biggest to the lowest, I'd like to be within 2 centimeters so we can at least have some consistency. So I'm just going to release the ball 3 times. And all I'm doing now, I'm not timing it, I'm just watching exactly where it lands, and I just use the reading. We can do that really accurate, and you need some practice of setting it back up. So I want to be able to release it 3 times and get as consistent as data as possible. Ideally, it would be within plus or minus a half of a centimeter. So I just do that 3 times. Obviously, you have multiple people in your lab, so you'll have one person keep track, do the iPad. You don't need the iPad for the distance, you need the iPad for the time, and you should be able to get a really close-up picture because you know how far it's going to go. It should be pretty consistent. So you have one person drop the ball bearing and then the other person do the iPad. And I'm obviously not really recording, and so I need that time. That would be time T2, and I need that distance. That is distance X2. After I find my X2 and my time 2, there's a whole series of calculations we need to make. The lab notebook will walk you through it, as will the instructions. My lab notebook in this case is not going to give you the formulas. It will tell you what variables you need to use, but you should be able to look at your worksheet and decide what formulas you need to use, because we're getting close to test time. So now's the time where we need to be able to see a problem and pick the correct formulas to use. So the general idea is I've measured this distance, I've measured the time, so I should be able to calculate backwards and find the velocity of the ball bearing coming off this ramp. And from that, and I know my height, I should be able to figure out what the acceleration the ball has coming down this ramp. That's A1. I will also eventually need this acceleration of the cart on the ramp because it went from moving to stopping. So we should be able to figure that out. So you're going to need to do all that. Then you're going to add 5 centimeters or 0.05 meters to whatever the distance was, and that's how far we want it to go now, which obviously means the ball is going to have to be going faster. So I have that distance, the new distance, and I work backwards from that new distance to figure out the velocity I need. I know the acceleration of the ramp, so I figure out how high I should release the ball. Remember, when you calculate your release, if it's 70, then you're going to have to be 70 from wherever this ramp is level with here. So it would be like 76, 77, 70, something different. Depends on how your setup is. Okay, so remember, if you get an X of 70, you can't just release the ball bearing from 70 because that won't be high enough because the ramp doesn't start at 0 here. So that's something to keep in mind. And then after you do that, after you figure out what it's supposed to be, you just simply stick the ball up there, up high on the ramp, and let it go and see how you do. Now if you let it go and it hits the clay and it bounces all crazy, now that probably should work. That really, the conservation momentum should apply as long as it stays on there. But if your ball flops out or the clay comes off the cart, then try it again until you get some good data. If your data is way off, I would definitely try it again and see how close I am. You might even want to take an average of 3 and see what you get. And that's really, and then you take the percentage difference between what you actually got and what you were trying to get. And that's all there is to the lab. So there's not a lot of data here, but there is quite a bit of calculations and using your formulas. Good luck.